A runner whose weight is 515 newtons travels from rest to 12 meters per second in 4.5 seconds. What force did the runner exert? All right, let's start with the givens. So if I look at the givens, I know the weight of the runner is 515 newtons, and he's going to travel. So if I made a little diagram even, here's going to be my runner. Again, not an artist, just whatever. Here's my runner over here, and here's my runner here. He's running faster. So here's the runner, and he starts off at initial velocity of 0. Doesn't look like it, but it is. Final velocity is 12 meters per second, and the time to make this trip is 4.50 seconds. All right, and of course I know his weight, which I really can't do on the diagram necessarily. 515 newtons. All right, so the beginning of the story, I know the initial velocity starts from rest. I know at the end of the story, he's going to be traveling at 12 meters per second. It's pretty fast, about 25 miles per hour. And the time is 4.50 seconds. All right, the question is, what's the force? So if I want to know what the force is, I've got to use Newton's second law. So I'll start with F equals ma. All right, that's great, but I don't know m and I don't know a. But I do know the weight. So the weight is mass times gravity, and I can also find the acceleration because I have these kinematics variables, which are very handy. So I'm going to use kinematics to find the acceleration. If I look at this, I need an equation with v, v naught, a, and t in it. So I'm going to use VOAT. V equals VO plus at. VOAT. In terms of the order, I'll do this first, second, and then I'll put them in. That's my third step. So now I got a strategy. Let's get busy. All right, kinematics. So V equals V naught plus AT. Isolate A. So AT is equal to V minus V naught. So A is equal to V minus V naught divided by T. So A is the final velocity, 12 meters per second, and the time, which is 4.50 seconds. So the acceleration in this case is going to be 2.6 repeating meters per second squared. Great. Now I got to find the mass using W equals mg. So W equals mg. M is equal to W over g. That's going to equal his weight, 515 newtons, divided by the value for g on the Earth, 9.80 meters per second squared. So in this case, my mass is going to come out to be 52.55102.041 kilograms. So now for the last part, using F equals ma. F equals ma, so F is equal to the mass, 52.55102.041 kilograms times the acceleration, 2.6 repeating meters per second squared. And when I do that, I get a force of 140.13605 newtons. If I do this with 3 sig figs, what I'm going to get is the force equal to 140. I'm going to put a line over it, and that means it's significant. In other classes, the 0 means repeating, but it means the number is repeating, but you don't have repeating zeros. So that's another way of indicating that last 0 is the one that's significant. If I was doing scientific notation, I get to 1.40 times 10 to the second newtons. Oops, forgot newtons.